this project with my colleague Dr. Sultan Sagabi, Munira Al-Buhairi, and Ammar Baghdadi, Turkiya Jayan, and me. So first I'm going to introduce this project and the methodology that we did, and I'm going to present the result and finally conclusion. As you know, there are most of people are using cosmetic and personal care goods for their daily uses, and most of them, they do have a toxic material that penetrate through the skin to their body, which they do have a very negative impact and effect in the human health. And in this project, we did collect some cosmetic material from the market, such as eyeliners, lipsticks, and nail polish, and we did analyze them by using ICP-MS and investigate their content to study their effect in the body. Most of the natural and synthetic substance that we do have in the market, they do have a negative effect in the human health. For example, lead is very harmful heavy metal, and it can affect the adults and children, and it does affect their brain and nervous system. So in this project, we do investigate the concentration of this material in the cosmetic product that available in the market. So the methodology, the samples were collected from the market. We did have 5 eyeliner and 3 lipsticks and 2 nails polished from various step brands, and we did digested this material into a solution to assess the heavy metal concentration. The table in the left is the microwave heating setting that we did use, and on the right is the ICP-MS setting. These are the results, and it is clear that it's clear that the heavy metal levels for most of the samples are above the permission level in many countries, especially, for example, US and Germany and many European countries. For example, the permission levels for lead is 10 ppm, and for the arsenic is 3 ppm, and for the cadmium is 3 ppm, and mercury is 3 ppm, and antimony is 5 ppm. But for example, in the sample number C1 and C5 in the table, you can see that the arsenic and lead and zinc and copper, their level it is clear that they are above the permission limits. Also, you can see that the arsenic in the sample number C5 is above the permission level, while the cadmium concentration in sample C1 is higher than the permission level. This is the analysis for the lipstick and nail polish samples, and it is clear that most of the elements are below the allowable level. They did show a good. They are within the permission level, but the concentration of chromium and nickel and copper in the sample C9, which is the lipstick, is higher than the others. To conclude, the concentration of lead in eyeliner in C1 and C5 sample are higher than the permissible limit. The arsenic concentration in C5 sample, which exceeds the permission limit. And finally, the lipstick sample in C8 and C9 had evaluated for the arsenic concentration, they reach the maximum allowable limit. Thank you so much.
Yes, sir, you can open your second presentation, sir.
Yes, for the second one, can you see it now?
Yes, sir. Yes, sir. Please continue.
Okay. I mean, the ICP-MS, which is inductively coupled plasma mass spectroscopy, is a very powerful and widely used technique to determine the concentration of elements in different environmental samples. In this study, we I mean, because it is widely used for different applications, especially for environment sample. In this study, we did evaluate the determination of calcium in different samples in environmental sample, and the effect of using hydrofluoric acid to extract calcium from them. There are many ways that can be used to evaluate, to prepare a sample for ICP-MS analysis. But there are two common ways. The first one is lithium metaborate flux fusion, and the second one is using a microwave digestion. When we use a microwave digestion, we need to use a combination of acid mixture. For example, hydrofluoric acid, nitric acid, and hydrochloric acid. But when we have a calcium in the sample, the calcium deposit out of the solution, which means the results are unreliable. So in this study, we demonstrate addition of hydrofluoric acid to the sample with different concentration in order to study the effect of using this acid. I mean, using this acid would provide inaccurate results. We did use, so this is a methodology that we did use. We did use natural ore and gypsum phosphate and cement and gypsum to as a sample in our study. Also, we did use in the left table, this is a microwave setting analysis, and on the right, ICP-MS setting analysis. This is the samples this is the result that we got. And it is clear that, I mean, for example, the first one, IAA sample, this is a reference that we did use in order to maintain the quality of the measurement. It is clear that using hydrochloric acid in the digestion system will lead to deposition of calcium, and it gives us inaccurate result. For example, the average calcium concentration in a sample of just gypsum phosphate is when we add hydrochloric acid is evaluated to 12,000, while when we don't use hydrochloric acid, while we got it higher when we don't use hydrochloric acid. We did use 2 mils hydrochloric acid in the first column, and we did use 0 hydrofluoric acid in the second column. In addition, we did use the third method in order to verify our results. For example, in the first one, we did use 2 mil hydrofluoric acid. The second one is 0 without hydrofluoric acid, and the third one is 0.5 mil hydrofluoric acid. It is clear that the concentration in the first column is very low compared to the third one, while the second column gives a high concentration. For example, for the S2, we got 140,000, while we got it 327 for the 0.5 ml of hydrofluoric acid, and we get it for 140 for when we don't use hydrofluoric acid. So 9 sample where we did use 9 sample in this investigation, and the clear statement here is adding hydrofluoric acid to the sample lead to the deposition of calcium, which may give inaccurate results in the case of estimation. Thank you so much.